All right, I think it went live this time. Seems like it didn't the first time I hit the button. Testing. If anyone's already here in the chat watching, let me know. You can see and hear me. Looks like everything should be working, but let me open up the stream as well. Just to double check, how's everyone doing? Also, if you want to put in the chat where you're watching from, I think that's always fun. And maybe if you're working on something, learning about something, like are you building something with computer vision, object detection, anything else in the AI area, let us know in the chat. Cool, and someone said hello. Perfect. I'm going to wait just a couple minutes as people are kind of tuning in. And they said they're watching from New York City. Cool, cool. I'm streaming from Seattle here on the West Coast. And while people are tuning in, again, I see more people joining. Say hello in the chat. Maybe share us what you're share something about like what you're working on. And today is going to be a hopefully a fairly quickish probably workshop building a pipeline to run DETR, which is a detection transformer for object detection. And if you want to jump straight to the code, as always, you're welcome to. I'm going to share the direct link to what we're going to be running in the chat. Also, I'll just share. See that's the full link. There's a other workshop material too. So if you want to check out, everything else, you can just go to the workshop repo directly. But this is under the folder tutorials and then DETR object detection. And I shared the direct link to that. And then also, so this is a little bit of an experiment. And I'm going to walk through all the code. And I encourage you, if you do want to follow along, that you could do so locally, following kind of the instructions in the GitHub repo. There might be a couple things you have to change to connect to the Union instance we're going to use. But you can do this all in the open source. The only reason why I'm actually really not choosing to have the pure open source for the workshop is I know not everyone will have a local GPU. So if you sign up on Luma, at least if it wasn't just now, you should be onboarded to a cluster that you'll be able to access a GPU, train a model, and then we'll deploy our model there to actually perform object detection as well. So yeah, there's going to be a couple ways to run this. I'm going to use the Union cluster for the workshop, but you can do all this locally on the open source. And again, the only reason I'm not actually doing that is in case you want a GPU and you don't have one. But I'll walk through what you might change if you are running this locally. And then also a little bit of an experiment. But if you do want to follow along, I tried to make it even potentially easier. But this is very bare bones looking in this notebook, but this just has all the commands you actually need to run to do this in Colab. So it's a pretty common question. When I would set this up to show the code locally or in GitHub code spaces or something, people really, really want to run everything in Colab, which I totally get. Makes it really easy. So there is a tutorial notebook here. You can see it's very bare bones. I'm going to add more to this later. I did this just right before we went live here. And what this does is it has all the commands that you actually have to run here to get the pipeline running and the models deployed. But I'll walk through all the code on my machine locally, although I'll show how you can see it in Colab as well. So a little bit of an experiment. I think for the next workshops going forward, what I'm going to do is make versions of both where I'm going to walk through the code locally on my machine, and then I'm going to have this Colab that people can run too. So I guess we'll see how this goes. But I know that people want to use Colab a lot, and it makes it really easy for actually running things. So I made this, again, bare bones here, but I'll describe what's going on and what code this is all actually running here. So definitely poke around the repo. I'll show this one more time for people joining in, and then I'll get going on some of the slides. So I'm going to go through some slides, again, hopefully pretty quickly, but as kind of people are joining in, and then also just setting the scene a little bit on what we're going to build, why we might want to build it, etc. And what we are going to build is a pipeline that's going to train a DETR computer vision model, again, detection transformer. It's going to pull in a data set. Then we're going to train our model, and we'll see kind of how it performs over time. And then we'll evaluate the model, and then we'll do a kind of little inference demo. Oops, I chose a poor one here, but it'll actually draw boxes on this side when it works, which if I go to a different run, It's doing some hyperparameter tuning. And I'm using a very small data set today for the workshop. You'll want more data than what we're actually going to use, but you'll be able to bring in your own data set. So this one performs good. And we'll see that this is actually doing object detection around these objects that we're going to train. And this comes up in a report here that you can validate. If we look at the training task, we can see that the loss is still going down a little bit, and the MAP, that measures intersection over union, basically between these boxes. Maybe I'll talk about this a little bit more later. But for measuring object detection, you're not just measuring classes, like the accuracy of predictions on what type of class was there. It's actually where this bounding box is drawn and how close it is to the original annotated data. So again, I'll go through slides and then we'll walk through building that, but hopefully that looks interesting to people. And again, I saw a big chunk of people come in. So if you do want to poke around at the code yourself, encourage you to go to the GitHub. And then also we have a Slack channel. So if you want to ask questions later about this workshop or keep up to date with anything else we're doing, or just talk with the community, it's I think getting closer to 6,000 people in there now. Go join the Slack channel, say hello in there. There's an introductions channel too. And you can give a little bit of a longer intro about like what you're working on. So again, this is a DETR pipeline for object detection workshop. I kind of showed you, if you were here a minute ago, what we're going to build. And here's an example of object detection. A tiny bit about me. My name is Sage Elliott. I work at Union AI. We're core maintainers of Flyte, FLYTE, which you can see it's in our Slack channel. I don't think I shared the GitHub yet. I'll share it in a second, but that's a open source orchestration tool. So we're the core maintainers of that. And again, everything that you see today, you could do in the open source as well. We're just going to use a Union cluster so you can have access to a GPU if you don't already have one. And I'm in Seattle. That's where I'm streaming from right now. Again, people who joined in, say hello in the chat, maybe put where you're watching from as well. It's kind of fun to see. I also run a AI book club where we read a new book every month. You potentially have seen me there. If not, and you want to join in and you have book recommendations, again, join the Slack channel. We usually talk about it in there. And previously, before Union, I've done a lot of work in computer vision, ML monitoring, evaluation, ML ops, and then also have a whole previous career in like hardware. And I combine that sometimes doing like robotics with software too. And I'm actually really excited to do more of that this year with some really cool stuff. So if you want to stay connected with me as well and ask questions on LinkedIn instead of the Slack for whatever reason, feel free to follow me there or connect with me and message me any questions too. I love building robot stuff, like hobby robotics is what I'm doing a talk on here from last year. So what is object detection? Has anyone built an object detection model before or ran one? I think it's pretty interesting if you've done it on your own custom data set before and you kind of learn a lot. But yeah, let us know in the chat. Has anyone built an object detection model? And if so, and you remember, what type of model did you actually end up using? So object detection, as you can kind of see here, and you probably have a hunch even if you haven't built something with it before, you're detecting and well, I should probably say you're classifying and localizing objects within an image. And so here you can see that we have two classes in this case. Like there's these two stickers, one is Union and one is Flyte. And we can see that there's purple and yellow boxes around them. So what this is doing is classifying an object and then also drawing coordinates of where it thinks that object is within a bounding box. So what you get returned here with an object detection model is one, a class and like a score of confidence that it thinks it belongs to that class. And then you get 4 coordinates for a bounding box. So 4 XY coordinates. And that's basically what gets returned in like a JSON type of format. And then you can draw this out in an image like we're doing here. And object detection does it opens up the field of computer vision for so many different use cases. Like if you've done classification before, you're just saying like, oh, I think a cat or dog or this type of stickers in the image. Object detection tells you where it is. And with that, you can do so much different things. Like one, automatically you can count how many things are in a frame. Then you can also use object tracking to kind of see behavior over time, which is like another algorithm you would lay on top of this. And that's really good for counting like things going through something like a gate or counting cars on a highway or counting cattle. I actually did a lot of agriculture projects in a former job. So we actually had one of the best cow counting models. There's all these different use cases, all these different fields that you might not think about if you haven't worked in, but like agriculture, healthcare, object detection is just so powerful and unlocks like huge ROI on bringing computer vision into so many fields. And there's a lot of cool stuff you can do with it besides just like exactly seeing where something is. You can also see when they overlap with each other. So it could be interactions between two objects, like when it collides, do something or send an alert. You can also see where they are within a frame. So you could have a part of the frame kind of like segmented off and say when one of these goes into this area, trigger an alert or do something. So that's pretty common. Like if you're doing in a manufacturing plant or something like that for safety, and you want to see if someone walks into a zone when they shouldn't be there, you could trigger an alert that way, make sure they can move out of the zone. You can also do a lot with just the shape of the bounding boxes and get information that way. So what does a human standing up look like, right? It's like a tall vertical box like this, or yeah, vertical. But if they fall down, then it would be like a longer horizontal box. So you can just have these kind of hard-coded rules with the objects that you get in here, or with the bounding boxes that you get in here, and do a lot of really cool stuff with it. So the object detection just opens up like this whole world of possibilities of stuff that you can do. So I think it's really exciting. And catch you up on chat real quick. Someone said they've tried grounding with Dino, which is another form of, I forget what the whole Dino stands for, but it's another form of detection transformers, right? Or at least it's built on it. Someone said they just did a people detection model. For the people detection model, did you train your own data set, or did you use a pre-existing trained model and just look for the people class? Someone else mentioned, or the same person, I guess, tried grounding Dino for grasp point prediction for 2D images. And someone said it would be instructive to see how it performs on objects that are not part of those two classes. Well, in this case, because if we one, the data set's very small today, so we're going to see some issues with that. But this will give you the whole pipeline to bring in your own data. For these two ones, like I took a pre-trained model and then I fine-tuned it on these two data classes. So it's going to do very poorly trying to detect any other class, basically. As someone said, it would be interesting to see. Quick note on data annotation for object detection. So again, today, we're going to give you the tools to build that whole pipeline. But you hopefully want to like go build your own project later, bring in your own data. So there's a whole bunch of different labeling tools you can use. I used this called a Label Studio for this one. There's CVAT, there's Labelbox, there's a whole bunch of open source ones. I'm actually also working on something I want to open source maybe over the summer. That's kind of a cool data annotation tool that is built like how I would want to use, but it's not ready quite yet. But for labeling the object detection models, you would bring in your own images, and then you draw these, you set up the classes that you want, and then you would draw these bounding boxes around it. And if you're looking for something to get started, like you want to take this and bring in your own data set, again, you'll learn a lot by doing this whole pipeline piece if you've never done that before. Is one thing I always recommend if you're looking for images to label. If you have a pet, you probably have a whole bunch of images of your pet. So a lot of people have a dog or a cat. You could take those images, label them, bring them into one of the labeling tools, export them, and the pipeline today is designed to read Cocoa annotations. There's just different ways of saving your bounding boxes and class labels, basically. It's just like a specific style of JSON that gets saved. So you'll want to bring that in. And the data really affects your model a ton. I mean, like you normally would think it probably does. But a big thing to think about is the amount of data. So again, today, because I quickly made my own data set to show, it's actually very few images, and I would need way more images to make this more accurate. We might see some limitations of that today. So if I run this again, hopefully I have more time to label more data in between. But the amount of data is really going to affect it. And then variations too. So if you can kind of think about where your model is going to be deployed or changes over time, like these stickers are all trained on this background here of this wood. But if then I'm trying to detect stickers on a different color of wood or carpet or like a black background or something like that, I would want to have variations of that. You also want to have variations of lighting, different rotations, anything you can think of that you can get and collect data over time, usually going to make your model much more robust. Obviously, you want proper labels. If you miss labeling an object, that can also really throw off your model when it's training, because say, well, I was looking for all this, but then this one wasn't labeled. So now I'm actually kind of confused on what I'm looking for. And you want to have this ideally big enough to have a training data set, a validation data set to look at while it's training, and then a test one that you're going to hold out. And once you've tuned your hyperparameters, go run on that. And then DETR, which stands for detection transformer. It uses a convolutional neural network backbone to extract features like a lot of other object detection models. But then it applies a transformer and encoder decoder to kind of try to model the relationships between pixels. And so at a high level, what this kind of does is breaks down the images into sections. I think the original paper, which I'll share the link for. Oops. Well, accidentally opened this up, but I'll share this in here. If I think the original paper has it breaks images into like 850 kind of chunks. So imagine it's like turns this into a grid, and each section of that grid, there's like 850 of them. And then what it does is it tries to it treats them as a token. So like flattens them into the encoder decoder piece and then treats it like a large language model kind of does. And it tries to find relationships with attention between those sections. And so this is from the DETR paper here, these images, but I just put it into like a GIF here. So first it detects like this first elephant. It's highlighting the things that why it thinks it's an elephant. So obviously trunks are probably one of the big indicators for elephants. And then it finds like the back of the elephant, the tail, and it uses the attention layer to understand this is probably one object, and then it can draw the coordinates around it. And then same with the other elephant here. So go check out the DETR paper. And one big thing about DETR is that it's a little bit slower than some other object detection models, but there's a lot of different implementations now, and it's really catching up. So just my perception is I see a lot more people starting to use it, especially this year, probably later last year. And it's can be, again, you need to test these object detection models on your own data sets to really see how they're going to work. Benchmarks are cool, but you won't really know until you start applying it to your own data set. So this is pretty well suited to more complex scenes where maybe you have a lot of occlusions or things overlapping each other. A DETR tends to do pretty well with that versus some of the other object detection models like single shot multi-box detection or YOLO, which are very lightweight. And even I think from the benchmarks I've seen a little bit better than like some of the two-stage heavier models like faster RCNN. So I'm excited. Like there's different variations of this coming out now. Seems really cool. I haven't put a ton of DETR stuff in production, so I've been playing around with it, and I need to do some proper benchmarking against other object detection models myself. If anyone has actually compared these, let me know too. Like, has anyone done like YOLO or single shot multi-box detection versus DETR before? Someone asked, how does it work with 3D? So I haven't tried it on 3D stuff. It probably does work. Like, are you asking about like point clouds? I'd have to look that up actually. I've only kind of read mostly stuff on it for 2D, but it's a very good question. I'd imagine it would work for 3D. I just haven't done it yet. Maybe we'll look it up later because I would like to know too, actually. There's probably some research on it. Someone asked, have I used RCNN/YOLO? We use transformers and images just because that's the trend now. No, I think so. I have mostly used RCNN and actually single SSD, single shot detection versus YOLO, though YOLO is really cool too. YOLO has different licensing architecture, so a lot of people I'd worked with in the past didn't want to use their licensing or open source their project. So mostly I've actually probably used in production faster RCNN or a mask RCNN if you want to squeeze out a little bit more of the accuracy points. So the detection transformer, like I was saying, came out and it was kind of slower until recently. It's kind of catching up now with some implementations. And the idea here, again, like I was saying, I haven't benchmarked this, is that it can work better with the attention layer on more complex scenes. Like RCNN already works pretty good on a lot of objects with like occlusion. In theory, again, this could be potentially better. So this isn't just like a throwing an LM at it. This is a architecture that it is a transformer, but it's trying to do object detection with like attention. So I don't think this is just like a trend for fun to throw at it. But if you are looking for production stuff, I think in production, RCNNs and YOLO are probably more the thing right now, especially if you're doing lighter weight things. DETR isn't quite there on the lightweight side. So I actually just did a talk earlier this week on that, comparing YOLO, SSD, faster RCNN, and DETR, and kind of seeing the trends there. And so YOLO is pretty widely used. Obviously, I think most people, like when I ask people what they've heard of or used, it's been YOLO before. But because they're licensing stuff, I've also worked a lot with single shot multi-box detection, SSD, and faster RCNN. But good questions. And I mean, it's going to be questioning if you need this at all, the workshop's going to be using it. I think it's interesting to try. You could swap out models of the pipeline that you're going to see today. Like if you think the MLOps part of this is more interesting, you can swap it out with something like a faster RCNN. And someone said for robotic object detection, which model would be a good fit? It depends on the hardware that you have. So again, SSD, YOLO, look at those two. But if you have a little bit beefier hardware, then you could also look at like faster RCNN. And then also most of those too, talking about, I'm just bringing up stuff was in my talk from earlier this week. A lot of those, you also have a CNN backbone, a convolutional neural network backbone. And so, for example, a faster RCNN by default uses like the ResNet residual net 50. But you can swap that out for a mobile net, which then condenses your model even more, or it becomes a lighter weight model. And then you can maybe put that on your robot if it has a more limited hardware. And then also there's other quantization techniques or format techniques like exporting it to Onyx or TF Lite or what is it called now? Light RT or Tensor RT, which is NVIDIA's. So there's different ways of kind of choosing your model, making it more efficient, and then formatting it to put it in production. So I can't, and there's no one good thing. You'd have to tell me more about your robot, like the hardware, what the actual application is as well. And then for this workshop, we're building a whole pipeline that I kind of showed you at the beginning. So if you weren't here, I'll just show it again real quick. We're going to build this. It's going to train our data or pull down a data set, train it, which is also going to give us a cool little report here, evaluate, and then we'll run some inference, and then we'll actually deploy this as well and see how we can bring in a new image and get a prediction to it. And this is Union that I'm showing you, which is a kind of hosted version of Flight, which is the open source. Let me actually pull up the GitHub for that real quick. So if you do want to follow along or just set this up later, you can do this all in the open source that I'm going to show you today as well, just to be clear. But I'll give you a Union cluster to get access to a GPU for the training. So just kind of reiterate, if you haven't done a lot of stuff in production, maybe you've even built computer vision models, but you haven't built out a pipeline yet, and maybe it's been all in like a notebook or something like that. MLOps is usually, or I like to think of it as a set of practices and tools that aim to deploy, monitor, and then maintain your machine learning models reliably and efficiently in production. So usually you have a pipeline. It might be much more complex than this, but you're collecting data in some way, and then you're going to pull that data down or pass it over to a pipeline to train a model. Then you want to evaluate that model. And at this point, you can see how it's performing on like a holdout test data set. Then you might go back to this training step and you might adjust hyperparameters, or you might realize, wow, I really need way more data. Like we might realize that today on my data set. And then you need to go collect more data and then kind of start all this pipeline again. You're going to ship the model out somewhere, and deploying this can look very different. Someone's talking about putting it on a robot, right? Maybe that doesn't have internet connection later. Maybe it does. Once you ship a model out, ideally you can monitor it in some way. So this could be testing it like every once in a while, or you could go look at the data that's in production, label it, and see how it's doing. But also, one thing I just really like to do, if you're putting any model out of production, ideally you should be looking at the input and output in some way, and that can tell you variation that's happening. You can also see if data drift is happening. So if you train your model, again, going back to our example here, if we train our model just in this, like we actually are going to do this today, but then in production, the background changes or a new sticker comes in or something like that, well, then the data no longer looks like our training data set. And chances are our model is just not going to perform very well on it. So you want to build out this kind of pipeline where you can quickly get new data, train, evaluate, ship, and then build this out and do this loop, hopefully very quickly whenever you need to. And this is really important for putting models in production. When I used to work somewhere where we did more professional service type stuff and we'd build out like POCs, this really helped to build this as quickly as possible. And then maybe even put a model in production, which I always encourage like as quickly as you can. And by putting it in production, I don't always mean making the decisions yet with that. But if you put the model out on production data, you can see how it's performing. And then you can collect that new data coming in for production and then run this pipeline over again. And chances are your model is going to perform really good. So if you're building a POC with someone, getting to the production data very quickly and then showing that in your model, it's probably going to perform better than maybe other people you're competing for the POC with. So that's a really good technique for really anything. Like it's just going to make your life easier if you build a pipeline earlier. Otherwise, you're going to have to do it later when you're scaling or working with teams. So I think I already talked about this, but just I like to think about building this for or making your workflows reliable and efficient. You want to think about scaling. So a lot of people use Flight or Union because they're scaling up giant pipelines with massive data sets. Like actually a lot of self-driving car companies use us for computer vision, and they need to scale up compute, which I'll show you what that looks like. You define this just all in Python. You want reproducibility. So Flight is built on top of Kubernetes, and it orchestrates containers onto compute. So you get the reproducibility of consistent environments. Also, everything is versioned. So if we go look back and I can click on these runs, I have multiple ones running. Oh, I think somebody's actually running this. Awesome. So you can see that every time I ran this, there is a version involved with it. And then I can go back and see the exact input. So this could be like hyperparameters here. I can trace back all my data. In this case, this data is actually cached. So every time I rerun the workflow, it doesn't have to download the data set again. I can look at my training. Again, this is all logged per version. So I can go back and see exactly what happened. And this is also really nice when you're working with teams and like passing artifacts around or data. So like you could, if you're pulling a version of a model, you could always pull the latest one, or you could pull from a specific version here. You could train again, pull in that new model, do A/B testing, see which one works best. And then improved efficiency, just making it really easier for people to write these pipelines, which I'll show what that looks like in code. And then I'll just go through this super quickly. But some other things to like just to think about your pipeline here. When people come in and redo a pipeline in a modern way, and they end up saving like an insane amount of money and time, like it's a lot sometimes. And some things that really stand out, just when I ask people like, what is saving you the most time or money? One is optimizing for local and cloud development. So with Flight, you can run everything locally in several different ways. And then you can kick off a cloud job. So if you're building a pipeline, it's really nice to be able to iterate locally and discover bugs, fix those very quickly without having to wait for like something to scale up and start a cloud run and then debug there. So that's been one of the huge time savers for people, which usually equals money when you're paying engineers, right? Leveraging caching in the pipeline. So we'll see this today, but if you rerun a workflow, you can add caching to those tasks in that pipeline. So like you don't want to download the data set every time until it changes, pre-processed data. So you can just rerun the entire workflow very easily, but all these will read from a cache state. And then you can just change your like hyperparameters in this case for training your model. Task level resource management and containerization. This is a huge one. So for each task, we'll see here in the code here in a second, we're going to define, do you want like GPU, CPUs, how much memory, etc. And so if you're downloading data set, pre-processing, you're not doing that training piece, and you don't have you don't want to waste the GPU for that. We only want to use a GPU when we need it, like for training and evaluation. So we do this all in code as well. And then another thing is type safety. So if you've mostly done Python, you haven't worked with other typed languages, this might seem funny at first, but you want to define like the input to your function and what the output will be. And this will help you catch bugs quicker as well, and a better handoff for other team members. So you kind of can look at the code and say, oh, the input was, this model, and the output is a trained model, or the input was a data set and the output's a trained model. So MLOps has just like a ton of opportunities for efficiency, which often comes with promotions. And then so the code looks like this. Again, we'll go into the code here in a minute and actually run everything. I saw some people are already running it, which is awesome. So again, we're going to implement basically all this in Flight. You can check out the GitHub here. This is open source. And then defining the task. So this is like defining a environment that each task is going to run in. We'll type something like this. Again, we'll see our specific example of it, but you can give it a name, that you can give it requirements, like a requirements.txt, or you can do apt-get or all these other special things. This is actually how you define the Docker container here. So I don't know if anyone's written like Docker containers before, but here with Flight, you just do it all in pure Python. So you never have to leave your Python project. It just makes it really easy to work on what you want to, like your AI engineering, machine learning problem, and then you get access to like all the Docker images and infrastructure just directly in Python through this SDK. You can add secrets to the cluster, read them in, and set them as different variables. Here you set the resources. So we just say like, for this task that we're defining here, we're actually going to define 2 for our project today, but we're saying we want CPU, memory, and then 1 GPU, and it can also type the GPU like a T4 or an A100 if they're in your cluster. There's also reusable containers. So by default, each task like spins up a new container. And it is actually really fast now already in Flight and Union. But if you want to reuse that container, you can do that so you don't like you can load in a model once and then use that in different tasks. And then once you have that defined, so we have an environment here, then we just add a decorator on top of Python functions like we normally would. And that's basically it. You get that whole infrastructure piece that we were talking about. We'll see this in action here, but you get that declarative infrastructure that we see, versioning like we saw, caching we can enable, type safety. It's super flexible. This is like pure Python. By the way, if you ever use Flight V1, it had a little bit of a DSL, so you couldn't do things like loops in your workflow. There's kind of weird ways to get around it. Now you can just do pure Python, run it as a task. You can do if statements, loops, whatever you want as a workflow, which is awesome. So most things just will work out of the box, but there's also a pretty big plugin ecosystem. But a lot of times you don't even need a plugin because it's just pure Python. If you can run it in the container, you should be good. Get checkpointing, scalable. It's built on top of Kubernetes, so it will scale to whatever you have in your cluster as you need it. And then a super nice user interface like you saw, and SDK. And it's used by like thousands of companies, Flight and Union. So I can almost guarantee that you've like used a model that was trained on Flight, whether it was like social media, self-driving car, listening to music. It's all over the place. So this is the link again to follow along for the workshop piece. And I'm going to catch up on chat here. While I'm doing that, I shared this already. So again, if you want to set up locally, you can kind of follow along in here. But like I was saying, I know people love using Colab. And again, if you weren't here at the beginning, this is super bare minimum because I just put this together right before the workshop, but you should be able to run everything. And I saw someone running a workflow, so I'm wondering if they probably went through this. It's probably the quickest way. You can go here and you can hit open in Colab. And then I think this should work. Again, I've done only minimal testing, and this has the commands you need. And then I will walk through the code for these commands, which is what I'm going to do now. But I'll give everyone a minute to pull up these links, and I'm going to catch up on chat because I see some other questions there. Someone asked, how do I access the Flight cluster for this workshop? So if you signed up for Luma or signed RSVP'd on Luma, that's where the only place I can export your email. I can't do that, I don't think, on Meetup. So if you signed up on there, you should have access. If you didn't already, you can message me later and I can give you access for a bit as well. So just noting, you get access to this cluster kind of during the workshop. It'll probably be around a little bit after. So if you do want to test something else, you can on there. And then if you do want longer access to actually build something on, message me because you might get removed. Also, it's a shared project for this workshop. So you can put secrets and stuff in here, but I wouldn't recommend it just because this project is shared with people in the workshop. So just keep that noted. And you might not want to put any super sensitive data in there. So treat this as like a demo cluster that you can play around with. But again, if you want like a separate project or something like that to actually experiment with something, you can let me know, and we can, if you're working on something cool, we can probably give you a separate project folder. All right, so I'm probably gonna go and I guess show things from here, but I guess as a quick thing, let me double check. I guess that this will I can do it first in Colab, get you all set up, I think, and then I'll go through the code if that works for everyone. So this is Colab. First, you need to run this code cell in here, and again, I will add more to this later. What we're doing is git cloning the repo, and you need to do that if you're going to do this locally or in code spaces. And then we're going to change directory into the workshop's tutorial DETR object detection model. And then we're installing requirements.txt. And then we're also installing, you only need to do this in Colab or some sort of headless environment right now, is keyrings alt, because they don't have one installed. So this, if you don't install keyrings or a keyrings, when you try to run something on Union, it will keep asking you for authentication. So this allows us to save like the authentication in our headless environment here. And this is just setting up the keyring part 2. And then this is making the terminal output in Colab dumb, so to speak, is literally what they call it here. If you don't do this, sometimes the output for things that are more complex like Flight renders really weird. And so like if you don't have this and you're trying to authenticate, that link doesn't show up right. So that's what we're doing here. I ran this, it's set up very fast. And then what you want to do is run this. This configures your Flight configuration. So if I look at my local one, it creates this file basically. So we give it an endpoint. This is the try-v2 cluster that, again, if you had RSVP'd, you should have access to. We're setting builder to remote. So this is going to look at our environment configuration, and then it's going to build the Docker image remotely. So we don't have to worry about this locally. Let me zoom in here. Sorry. Is that good enough? This might be too big. Definitely the terminal is too big. I might have to resize this a little bit. And then domain is development. We can have several different domains. There's if you were able to get in here, you can see there's domain, staging, and production. So you can have different environments here that you can be playing around with. Org is try v2. This would be whatever org you're on, so your actual flight cluster or union cluster. And then we have a project. So if you had access to an actual org, you only have access to one project here for the workshop, but you can create different projects, obviously. So like this is workshop DETR, but I could have one for my object detection models, other ones for my LLMs, etc. Someone asked about Flight. Is Flight free to use for personal projects and learning, or are there any paid infrastructure resource costs involved? No, so Flight is free. You can go look at, I already exit out of here's a repo. You can go look at the repo. It's free here. It's just open source. I think the only licensing different stuff is on the UI, which you can still use for your projects. Then you can't just like resell the UI as another business, basically. But you can go look at this and check out. So the actual Flight project is under the Apache 2 license, and many people use this. So this is one of the widely used orchestration platforms. Like I was saying, you've probably used a model that was trained on Flight somewhere. LinkedIn runs all their whole ML infrastructure now, but like all their LMs and stuff, LM training is running on Flight. So a lot of huge companies use this as their orchestration piece for building those pipelines, just kind of like we saw. And you're seeing Flight 2 right now. So this is this UI. If you've looked at Flight before, or if you come to like a workshop or something that I did like a year ago, this looked pretty different. And this is the V2 of the product that you're seeing right now. So a lot of people are still on V1, and then V2 is very new. There's a lot of it is out in the open source, but there's still some work we have to do, and I think a lot of that's coming out in the next month or two. So keep an eye on it. But you can go ahead and get started. You can just pip install the Flight SDK. And by the way, the SDK, without even Docker setup, you can run Flight workflows in there and add a flag, like you say at local, and it'll run locally. And you can say TUI. It'll give you a terminal user interface. It gives you like a more minimal version of what you're seeing here, but you still get caching. You still get all the saved iterations. So if you do want to look at like the hyperparameter tuning and you're doing this all locally on your own GPU or something like that, it's really nice. It's really nice for building agents as well. So this is Flight I'm running, and it's very similar to the other UI that you're seeing. This is just white and purple now, but this is running on something called DevBox. So if you install the Flight SDK just with pip install Flight or uv pip install Flight, then you can run Flight start DevBox, and I'll give you kind of a local version, this whole version thing that you're seeing here, and you can do all the stuff that I'm going to show you in the Union platform, but locally. And I even have instructions in there if you're running on like a DGX Spark. There's just a couple small things you have to do. And that's what that one's running on. So if you actually look in the code here, there's some comments to run this on a Grace Blackwell chip if you want. All right, sorry, got sidetracked there. The tutorial here that wrote my config, and then you can run this. I'll run it from my terminal, but if you run this, then you'll actually kick off a pipeline if you have access to it. Actually, I guess if I run this here, it should ask me to authenticate, I think. So it's building an image, and I guess I had already run this in this instance, so it didn't ask me to authenticate, but you should get a URL. It says, please authenticate here, and then click on it. And then one thing to note, because the output's a little weird sometimes in Colab. So you can see that this link is broken here. It's saying, hey, the run is created. Here's the run ID. But you can see this is broken. So if I click on this, it's going to say error, page not found. And it's because it broke to a new line here. So you could copy the whole thing in and fix this broken line. Or you could just go click on run, like go into the UI if you have access, click on runs, and then go navigate to the ones that are running here. So I clicked in, I can see this is running. And I've already showed a few times, but I'll show what the full run looks like. We get the prepared data. This is actually then written to cache. So when we rerun this whole workflow, it shouldn't download this again. And then we get our train model. And again, I'll show the code here in a minute. We can see in here, this also maps our loss function over time. And so this is a report. So inside Flight, again, whether you're doing this locally, actually, even if you're doing this locally, not in the dev box, you can write reports as well. And they get saved with versions, which is another really nice thing of just in the SDK without even Docker. I've been using that for like personal experiments when I don't need a whole kind of Docker thing going on. But you can write reports like this that get saved per version. Again, every time you run this, you can go back and see these reports. And this can be any HTML or Markdown file that you want to basically save and link to this training run. So we have our loss here, and then we have our MAP, mean average precision of those bounding boxes. You can see it's actually really high for this run. And then we have a learning rate scheduler here as well. But you can really map anything that you want in here, which is super convenient. And then we do that with evaluate. We have another report here. And in fact, if you look at the code, a lot of the code is HTML because I need to break these out. I didn't. I should break these out into another folder or section. So in the workflow.py, there's not as much HTML there. It looks like there's so much going on, but it's really just HTML for like writing these nice looking reports. And then in our kind of inference demo, and I like having a step like this most of the time when I train a model, is just throwing like another variation or one of the validation variations in there, and then like being able to see how it performs here, even though we had this whole evaluate one where we have these metrics, but I actually might want to see what this looks like. And this can really help too if your metrics aren't good and you're like, wow, like something's clearly wrong here. And you might see that it's drawing boxes in a weird place or something like that. So I always like to have something that like shows me what the visualizations look like, either for reading in the data set originally or when you're doing predictions already on it. Oh, and then, well, I guess I'll show before I go into the code. The other parts is these apps here. So if I go to this detection UI, we have one that's a fast API server for the model. So the model gets trained in that workflow that we saw. Then we're going to take it and serve it on an API endpoint. And then we're going to host it, then we're going to host a Gradio app too. That's the UI to interact with that model. And it's taking a minute to open up because you can see there's are actually 0 of 1 replicas. So in the code here, which we'll go in deeper, but just like we kind of saw for creating our environments for our pipeline, is that you can set resources and scale. So like this will scale down to 0, go back to 1 after 30 minutes. So this will stay up, and then it's redeploying right now. But the model one might take a second. So actually, let me go in the code while that's going. First, we have our config.yaml that we already set up. And then you could set this up directly in the workflow.py if you wanted. It's pretty flexible, but I have a config.py. And this is where I'm setting up my variations of the environments that I want to run my tasks in. So I have a base image that I'm calling a real-time DETR detection v1. I should actually maybe change this. Well, I'm using DETR v2, but it doesn't really matter. The name here, you can name this whatever you want. And then we're going to read in requirements.txt. And this is going to build our Docker image. Again, you could add other stuff here like specific CUDA versions, apt-get, whatever you need to add into your Docker image. And then I have 2 variations of the environment. They're all using that same image, but they have a difference of compute that I'm allocating for them. So I have this one for a GPU. This is what I'm going to use for training and evaluation. So I'm setting CPUs to 4, memory to 24 gigabyte, and then giving it 1 GPU. And then I have our CPU environment here. And actually, I would need to double check this. I might be using too much memory here. We can maybe look at the metrics here later, because if it's all in the GPU, I might actually need way less memory if it's all running on the GPU, probably. So I could probably save money if I'm doing this a lot by bringing these down. We can actually look at the metrics in the run probably. And then I have our CPU one. So same thing, same image, but just way less memory, way less CPU usage, because this is just used for like downloading the data set, pre-processing steps or anything like that. And then the GPU is used for everything else. And if we go to the workflow.py, like I was saying, there's a lot of HTML in here. I need to clean that up and put it in like a special report section. So if we go to the workflow.py, we import the stuff that we need. And then this is the report CSS. Again, I'm going to go through, I'm not going to bore you with all the HTML here. This is what makes the reports look nice that we just saw. Same with making nicer charts. Let's scroll down all this. Like I was saying, I should break these out. They'll be much cleaner. Here's our first actual task here. Task 1, prepare the dataset for download. And this is pulling in a dataset that I just put onto Hugging Face, but you could bring in your own dataset as long as you put it somewhere like on Hugging Face, which I recommend. It makes it really easy to bring it to different devices. Or you could use a pre-existing one that has like a Cocoa annotations. So you can see that we had created our stuff in config.py with that task environment. So we're calling that CPU environment here. We're also enabling caching. So the caching, again, when we rerun the entire workflow, this won't rerun again. So if we actually looked at our run here, oops. If we looked at our runs and we go look at this, this is probably run for the first time for somebody. So then it says cache populated. If we reran it, it'll say read from cache, basically. Cool, and I can see other people are running this. Awesome. And then we're going to get, by default, it just takes in that data set that I have, but you can swap this out. So again, if you make your own data set, host on Hugging Face, you can swap out this URL, or in the command when you call it, if you look at the README, you can say, give it a, like when you call the workflow from down here, like I'll do here in a second, you can add a flag that passes in a data set. And it's going to split 20% of it for validation. You could also have another split for a test, which I would recommend too. But this is going to download the data set from Hugging Face, save it, and it's going to output it as a flight directory. And flight has concepts of files and directories where if you have it output as that type, it actually gets saved to like what would be your blob storage, like S3 if it's deployed on AWS. Because if you've never worked with containers before, each one of these by default, unless you're using reusable containers, each one of these spins up and then it spins down. And so any files or anything that you do within that container no longer exists once it spins down. So you want to have something like flight file or flight directory where it'll pass it out, but it actually saves it to blob storage. And then you can read it into the other container, but it kind of behaves as if it was a local file now, which is really, really convenient. If you've done a lot of work with like containers, it can be kind of annoying. So that's what this function does. All this other stuff is basically just pre-processing, reading in those bounding boxes and annotations. So if you don't have something stored as a Cocoa data set, there's different annotations formats, but I think Cocoa is the most popular. Then you would need to redo this kind of reading in annotation parts. And then we're building a Torch data set. So PyTorch has a way to read in images, and we're doing this again, just basically bringing in the images and annotations. We're also adding in some augmentations. So with computer vision, it's pretty common that if you're doing anything from classification or the object detection side, that you want to add some slight augmentations during the training part. So what it will do is do like flipping the image a little bit or adding different brightness or contrast or different hues or rotate or random scale. So it gives a little bit of variation to your images without you having to collect all those different variations. So it's going to make your object detection model a little bit more robust. So we read that in, we add those augmentations, and then we have our train task. And this is going to take in that file that we just downloaded here. You set the number of epochs. Again, you can overwrite that when you call it. By default, it's 30. And we give it a learning rate, a batch size, and then this eval every number of epochs. In our report for training, you'll see that it gets the loss, but then also every whatever number of epochs that we pass in, it's going to run that on the evaluation data set and see how well the mean average precision does on actually detecting the bounding boxes. So this can be really helpful because your loss might be going down, but then something else is just making your model not perform well on the actual detection piece. So I like to add in a piece where every certain amount of detections or epochs then run an actual detection to see how it does. And again, a lot of this is just working on kind of the report here with this HTML. This is that every n epoch evaluate. And then the actual training piece, again, some more building reports. So again, like I was saying, I need to clean up this HTML. It makes this look really, really big. We scroll down. So this is the on epic piece. So it looks to see if it's on that number that we pass in, and then if so, go ahead and do the evaluation. And then here's the actual training piece. Or here's training parameters first. We're going to set it to run on CUDA. Again, if you're running this locally on a Mac too, you might want to set the, instead of device to CUDA, to MPS, the metal hardware. And then we're going to pass in training arguments. So what's the output directory? The number of epics is all stuff that we passed in earlier. Logging steps. And then we're just going to call train.train. Train.trainer, or sorry, trainer is equal to trainer, and this kicks off the actual training run here. So we pass in that model, and then all those training args, the training data set, and the metrics that we're calling back to. And if where is that part in here? Because again, there's a lot of HTML code. One important part is when we set our model. Let me just find it real quick in here. Because we're training on a custom data set with different amount of objects in it than the original one. So like, I think the original Cocoa dataset has, I think it's like 80 classes. So when you first download the DETR model from Hugging Face, it's going to have those 80 classes, and you want to overwrite the config of that model to have the number of labels that's in your data set here. And that's pretty common with other object detections too, like detection models like faster RCNN, like we talked about earlier. Like you kind of chop off the detection layer at least, and then train that part with the amount of labels that you're detecting. A couple helper functions. This just reads in, or you set the model to evaluate, so not training anymore. And then this does the evaluation piece for the evaluate function, and then also for the evaluating during the training. We have a drawing boxes, because again, you just go get these 4 coordinates where in the image that detection is, and then you want to draw that out in a box. And then we get the image data to our URI. We want to convert the image to base64, so it can be embedded directly in an HTML report, and that's how we're able to see in this part. And then this is the evaluating task, which is, sorry, this one. So we're going to bring in the model, the data set. We're going to run the model on the evaluation set, which was like that 20% that we set originally. And then we're going to return scores at these different levels of MAP, which a mean average precision is calculated for basically that IOU, like I talked about for these bounding boxes. I should put a whole slide on this, but if you have, for detections, you don't just calculate the classifications, you calculate how well these boxes are drawn versus the annotated ones. So to my eye, these look pretty good here, but if it was skewed off, right, that would have a lower IOU, intersection over union. Or if it was too much inward, or like too drawn way further around it. That's just the score telling you basically how bad the box is drawn versus the ground truth annotation. And so it's pretty common that you're going to run these at different rates for your object detection models. So you'll see like mean average precision at 50, or like 50 through 95. And so this is giving you different scores for those precisions. In our case, they're all great. Looking at this inference demo, you can see it did a really good job. So it's actually at like 100. And again, we have a very small data set today, so it's like basically probably overfitting on our training data set, and that's fine for the demo today. But realistically, your score probably wouldn't be 100 there. Oh, and then the mean average recall is measures how many ground truth objects the model finds. And then we had our one other task, which is the inference demo. This just reads in the model like the evaluation one, but it draws the boxes on top of it. So again, it looks like a lot of code here. There's just a lot of HTML converting the images to base64 and basically drawing these detection boxes on them. And then we put it all together into a pipeline. So we had all those are individual tasks, and now we can just make another task that calls tasks. So if you did use Flight V1 before, we had a workflow decorator, and that's where the DSL part came in, where you couldn't do like loops and stuff like that. In V2, everything is a task, and a task that calls other tasks. That could be your pipeline here. So we're going to pass in the we're basically going to call every function that we had defined above as a task, and then that'll get kicked off into that whole pipeline here. And again, we create another report and stuff in here as well. So we'll get a little report at the end. It says, again, our validation image was just 3, very small data set. Say the MAP was 1, which is very good. Again, overfitting our small data set today. That's fine, though, for the demo. And we could put whatever we want in this report here. So I go back real quick, too, to the apps. So they should be spun up. We'll get this little UI, and I'll show you the code for this next. So this is a Gradio interface. I'm going to click and upload an image. See how it does on this one. This also should pull in the latest model. So if someone else trained a model while I was talking, it might pull in that one, and maybe the MAP isn't as good. We could see that it's doing detection on the union sticker. We might need more data and maybe more training time to get to work better on the flight sticker here. We put this as low as possible. So this is the confidence threshold. And you can see now it's detecting flight sticker, but it's also thinking the background's a flight sticker with this confidence threshold. And so we just need to train this more and definitely add more data set variation. But we went through, we trained a model and then deployed it. Let me see if there's a good threshold here to get both to work. Sometimes you need to do this anyway in production, but we could tell that our model's just slightly off on that flight sticker, but it learned the representations of the union sticker pretty good here. And then for the code for this, that's going to live in app.server is the fast API server piece that actually takes in that model and hosts it. So like the flight config that we saw for our pipelines, you can do this again for your serving piece. And it makes it really easy for this serving this app directly inside of Flight or Union. It makes it really easy to pass those artifacts to each other and actually have them deployed. So our pipeline basically emits a fine-tuned model from our data set, and then we can just easily pass the latest version or a specific version of that model. So if we go and look here, we can see this has a run ID. You can basically pass this hash in, pull that specific model that comes out of this pipeline, or we have it by default. If it doesn't have that passed in, it will just pull the latest one in the list of runs. So if we look at here, this is the latest one that someone ran from the workshop, and would pull that in, pull that model in. So you can give it a requirements. This time I could read in that from that same requirements.txt, but I put in with pip packages to show there's different ways to install this. Basically create your Docker image. And then we're creating an app here. We're going to call it Fast API. Give it a name. And then these are our environment variables, just like our pipeline, where we have a name, a image that we already created above, define the resources for the deployment piece. Again, we want a GPU, certain amount of memory, CPU, requires auth. If you're on Union, you can set this to false and then actually share out the link. And if people aren't logged into your org, they should be able to access this, but you could set this to true. So it would be hidden behind a paywall or not paywall, your org wall. So like you have to be part of that org. And if you're on flight, you would need this as like a remote thing. So it's not going to really work here if you're running this on a local cluster. And then here we're passing in the parameters, if model, and it's going to download that to true. And then this is the scaling piece. So we have this scale down to 0 when somebody isn't using it for 30 minutes. It's going to go down to 0. Otherwise, it's going to be at a replica of 1. And you could add this up. So there's also another metric that I don't have in here, but you could basically say how many people can visit an app before it scales up. So you could say like, you know what, 4 people on one replica of the app is fine. But when it goes up, then I need more, and I'm going to scale that. And then after 30 minutes, it's going to scale down to 0 in this case, but you could set the scale to 1, because if it's 0, that's awesome. You're not paying for that compute. But if someone visits the site, it has to take a little bit of time to spin that back up. So if this is actually in production somewhere, you might have this as like scale of 1 up to like 5 or whatever you want. And then we had a decorator on startup. This is going to try to pull the latest version of the model and then load it in. And then it's going to set our fast API endpoints. We just have our detect and classes, which will return our bounding boxes. And then it's basically just a pretty simple fast API app from there. And then the Gradio one is just a Gradio app that takes in that URL. So if you did deploy this, or you have another version of this, either locally or on a different hosted version of Flight on Union or something like that, you would have to probably change the server URL for this to pull in the right model. And then that's how we get our app served. And let me catch up on chat here. Oh, a cool thing with Gradio too. This probably won't work. I don't think it'll detect my shirt here. It's not trained on this unless it got a sticker in the background. But you can actually access webcam and like take a photo from there and then run detections. Again, it probably will see nothing or, oh yeah. Oh wait, union sticker. That's not a union sticker, but again, our data set didn't have variations of other stickers. So I was actually curious what it would detect, or if it would detect a union one. And then it's detecting, I can't see what it was. Actually, oh no, it's not the bottom union one. It's detecting maybe the Python one. But we can see it works deployed in production. Our data set needs more variations. If you actually look at our data set, it's only like 16, 19 images, so we need to add way more. Okay, so let me catch up on chat. I think there were some questions. We went through kind of roughly everything that I wanted to show you. Hopefully you thought it was interesting, even the slide part, if you hadn't like used DETR before or any other object detection models, or thought about an end-to-end pipeline, what it might look like. Hopefully part of this was interesting. Went through and built a end-to-end, really, I mean, our data set is simple here, but this is a production grade pipeline that a lot of companies are using tools very similar to this. So that could be Flight or Union in production for building these like pipelines and then deploying applications. So let me catch up on chat here. Let's see. The Flight one, I think I'd answered. I think that's the same one, but just in case, if not, let me bring back the Flight repo. And I'll be hanging around for questions too. So if you have any, let me know. Or just comments. If you thought something was cool or interesting, that's always fun for me to hear as well. And it seemed like the collab did actually, let me know if you're in the chat still and you ran the model, because I actually saw people running the workflow. Did you just use collab for that? Like, even though it was very minimal this time, I'll add more to this next time and have a little bit more of description and like pointing to code. But did this work well for anyone who actually ran stuff today? Because that's a really good piece of feedback for me for future workshops. Somebody said, sorry, they joined late, registered via Luma, but they can't. But can anyone tell me where you can get credits? So there's not credits per se. This is just a demo cluster that we have that you're onboarded to. So it's not a serverless product. Unions deployed in like scaled productions within orgs, and so they have like a license and they use Union inside their organization. So there isn't a serverless version right now with cloud credits. But if you RCP'd through Luma and you were early enough, you should have access to the demo cluster. And if you do want access for something, reach out to me on the Slack channel. Someone asked where to access the deployed app. If you ran that, or if you're in the org, because it sounds like you are from running in Collab, you can go to this little app tab, and then they should be in here. And I think we are all running deploying the same one. So even if you ran it, your version is probably going to be in here as well. So I'll share this out actually. And then someone asked how to access the deployed app. Actually, let me try this real quick, because we had auth set to false. Can you access this? Let me try in an incognito tab, I guess. Oh yeah. So you should be able to access this deployed app and try passing in an image. Again, it was trained on these things, so you might not have a flight or union sticker. It probably won't work very well, but you can see it work in production. Someone said they don't see it under apps. Oh, interesting. Well, if you, I would think you would. Maybe there is some permissions thing where you see workflows, but not apps. Maybe you need to deploy the app. Did you run the last two parts in Colab? So this runs the workflow that I ran. I ran this earlier. I guess I didn't actually show these two how to run them, even though I showed the code. So flight run workflow, that runs the workflow. And then there's the app server.py and app gradio.py. You need to make sure the workflow, or since we're in the same project, it actually will probably just pull from a previously ran workflow, which is fine. But if you're running it in your own project, you need to make sure that the pipeline finishes first because it's going to pull the output from there. But you can run Python app.server and Python app.gradio, and it should work for you. And someone said yes, or they said yes. I'm not sure if that was, you said you ran this, but you don't see. Oh, interesting. Well, it might be a bug in the demo cluster. It's probably like a permissions thing because again, this isn't like a serverless product here. This is like a deployed version with project folders, and it might be my hunch is it's a permissions thing for how I added people to it. So great note though. Let me take a look at that. Sorry that you couldn't access it during the workshop. If you run this on Flight, your own open source, without the kind of the org permissions thing, you should not run into that. I'm sure. Or if you were on an actual org in Union, it's got to be something with the demo cluster and the emails added. So I will take a look at that. Good to know. Good to know. Any other questions or comments before I wrap up the stream? I still see quite a few people watching, which is awesome. Let me know, or again, comments, like if you thought anything was cool, if anything was interesting. What was the most interesting part? And it sounded like the Colab thing worked for people, except for maybe the app deploying thing. I'll have to look at that. I guess, let me try running it. Yeah, I ran it from here. So it works for me. So again, I think it's a permissions thing. And I'll have to take a look at it. So again, sorry, but you can see what it looks like since I deployed it. Any other comments? Someone said they tried to activate, but authorization was denied. It is possible that you came in after I exported people from Luma. So I exported not that long before the workshop, but it was like probably an hour and a half or something before there. So that's potentially why you might just not be in there. But if you do want to play around with the cluster, feel free to ping me on Slack and I can maybe add you in. And again, if you're added in here, you'll probably be unboarded at some point, like maybe even later today, because there's temporary access to the demo cluster that we use for other things. So say they tried to activate, but authorization was denied. Does that mean it felt like you were in, but then something got denied later? I'll have to look and see. Again, if you ping me your email, I can see if you were added in there. Otherwise, if you think Union's actually something like interesting for your company and you want to talk with like an engineer and get a more personalized demo and actually maybe build out like a POC, you could fill out this form here, which could be cool. You might learn a lot of like building your pipeline. Otherwise, check out the open source. And if you have a GPU, if you have a local GPU, you can run like the pip install flight or the requirements.txt that were in this GitHub repo, and then do flight start dev box, and then I'll bring up a version running locally. Just one note on that: if you're doing that on a Mac, because it uses Docker. I don't think there's Docker versions right now that use the MPS, like the metal architecture, like GPU for training. But you can use the Flight SDK. So actually, like that lightweight version I was talking about. Let's see, this might not be set up to run. So this might throw an error, but I'll show you hopefully something a little bit. Is I can say flight run, and then instead of just flight run, which is going to go kick off the remote job, or on DevBox if you had set up, I could do local, and then I could do TUI, which is terminal user interface. And let's see if this works. It might not be set up here. So this is going to give me a lightweight version of everything you just saw, but just all local and without Docker. So like you don't get the scaling, you don't get the Docker reproducibility piece, but this can run locally on your computer, and you get this little terminal user interface that has the workflows, and you even get reports and inputs and stuff are all logged here. I think I don't have this set up to actually run on the metal. It's probably trying to run on CUDA or just CPU. So this is probably going to maybe not fail, but go really slow. So I'm going to stop it. But you can see like what I'm talking about, like everything that we had in the interface is kind of logged here in some way, which is really cool too. And again, the caching works locally. The inputs, outputs. This is really, really nice if you're doing like agent work. Yeah, I think I don't have it set up to run on Mac, so that's why it's failing here. But this is really, really nice for agents too. Like if you're running more than a couple agents at a time and you're trying to understand what's going on with just logging, it's really hard. But using the TUI like that is just really cool. You get the whole workflow tree and you can see what's going on in the state of them, which is really nice. Cool. I got to wrap up and go do some other work. But thank you everyone for coming. It was awesome having people talk in the chat. If you want to stay connected, again, you can connect with me on LinkedIn, or I recommend also joining the Flight Slack channel and say hello in there. There's the introductions channel. It's really fun seeing all the people come in and learning a little bit about like what they're working on. Totally recommend joining. And then if you want to, I highly encourage you to post in the intro channel and tell us like what you're building. With that, though, I'm going to wrap it up. Hopefully this was fun, interesting. I know a lot of people stuck around, so seems like it was interesting enough. Hopefully you had fun. And if you weren't able to run this during the workshop, go check out like the Flight SDK, check out the Flight Dev Box. If you want to try the Union cluster, ping me on Slack. I'll see if I can add you for a while. Again, you'll probably get deboarded a little bit later too, so don't think it's a permanent thing that you'll always have access to. But if you do want to test anything out, let me know. Hopefully you thought this was fun and you trained a end-to-end DETR pipeline. So I'll talk to you all later.